So today we're going to be learning about families of functions. So we've learned about functions, and we have something that are called parent functions, and they are the most basic form of a function. And there are going to be four that we're going to be looking at. Our linear function, which is just a line, which is f of x equals x. A quadratic function, which is going to be U shape, and it's going to be f of x or y equals x squared. A square root function, which is going to be f of x equals the square root of x, and an absolute value, where we have f of x equals the absolute value of x. Those are our parent functions. They are the most basic form of a function. Its family members are, you're going to take that parent function and then something's being done to them. They're either being shifted up or down, left or right, or they're being stretched or compressed, but they all start off with that parent function, that original basic function. Then we have a list of parent functions here. It's the simplest form of a set of functions. There's one that we are adding on to this, which is y equals the square root of x, or y equals the negative square root of x. This is the function in its most simplest form. The first ones are the positives, and then the second ones are the negatives of it. It's basically, they would take these lines and then flip them. Like this one would get flipped over, our absolute value would get flipped over, square root would get flipped over this way, and our linear would go this way. Okay. So, we are going to take that parent function and we're going to create a new family member, basically. We're going to be creating a new function with a type of transformation. There's going to be three types of transformations where we're going to focus on. The first one is translation. Translation is either going to be shifting left or right, or up or down. Okay? Reflection, we're going to be either reflecting over the x-axis or the y-axis. Or a dilation. A dilation is either going to be, we're going to be stretching, making it wider, or we're going to be compressing, making it thinner. Okay? All right. A vertical translation means that we're going to be moving either up or down. So we're going to take our function, our parent function, and on the outside we're going to either be adding to move up, or we're going to be subtracting to move down. And that's going to be on the outside of our function. Okay? If we're moving left or right, a horizontal translation, it's the opposite than what we're used to. It's going to go on the inside of our function, so it's going to be inside the grouping symbol. Okay? It's either going to be inside parentheses, or it's going to be inside the square root, or inside the absolute value. And if it's going right, it's going to be negative, and if it's going left, it's going to be positive. Okay? And this is the part that's a little bit opposite than we normally would think. Okay? Alright, so how are the functions y equals x and y equals x plus 1 related? So, this is on the outside, it's not in grouping symbol, so it's going to be either up or down, and it's a positive, so it's going to be up. So it moved up 1. Okay? It says, what is a new equation if y equals the absolute value of x is translated 3 units left? Okay, so when we're looking at left and right, we have to put our value on the inside of our grouping symbol. So I'm going to have y equals the absolute value of x, and we're going to have 3, and we're moving to the left. So left is positive. It's opposite from what we're used to. So you should be writing this down. Yes. Right. What is the new equation if y equals the square root of x is translated 1 unit down and 2 units right. Okay? When it comes to these type of equations, we always want to work with our inside out. So we want to work with what's going to go on the inside of our square root first. And that's going to be our left or right. So we're moving to the right 2. So am I going to be adding 2 or subtracting 2 to the inside? Subtracting, because it's the opposite. And then we're moving up, or down, down 1. So I'm going to, on the outside, I'm going to subtract 1. And that's going to be our new, this shouldn't be an X, not a Y. Sorry. Okay. Right. Translate the table 3 units up. Okay, so if we're thinking about a line, let's just pretend like this was this original graph. If I'm moving 3 units up, let's just draw a new graph. Pretend like it is the same. Are my X values changing? If this point got moved 3 units up, did my X value change? No, only the Y value did, right? So I'm going to be adding 3 to my Y only. So I'm going to have my X's are going to remain the same. So I'm still going to have -2, 0, 1, and 3. But my Y's, I'm going to be adding 3 to them. So 3 plus 3 would be 6. 1 plus 3 would be 4. -2 plus 3 is 1. And -1 plus 3 is 2. So my Y values change, my X's do not. Is it working? Okay. So you don't work on anything? Okay. Find something to do then. Okay. So that is translating translation. So that's moving left, right, up, or down. So reflection, if we're reflecting something over the x-axis, the negative sign is going to be on the outside of my function. It's going to get distributed to everything on the inside. It's going to affect everything. Because if you think about it, my x values change as well as my y values, because it just reverses it. It goes like this. Okay? But when we have our reflection over the y-axis, only my x values change. My y values stay the same, or the value on the outside stays the same. So it's only, the negative sign only affects the x. Okay, my y-intercept wouldn't change. Where here it would. So let g of x be reflection of f of x equals -2x minus 1 in the y-axis. So the y-axis is only going to affect my x, okay? So my g of x is going to be only going to affect the x. So it will go on the outside of my x value here. So this is going to end up being a positive 2x. But I'm still going to have -1 because my y-intercept doesn't change. Okay, so it's still going to cross my y-axis at -1. But my x's all change to the opposite sign. Okay? But if it's reflecting over the x-axis, my y-intercept and my x values would change. So everything is going to get affected by the negative. So I'm going to put my negative on the outside and then distribute. So this becomes -x squared minus 2. So when it reflects over the y-axis, the negative sign only affects the x, because the y-intercept would still be the same. But when you reflect over the x-axis, all of your x values will be the opposites, and your y-intercept is going to be the opposite, so it needs to affect everything. So that is reflection. Okay, so we talked about translation, so that's moving left to right, up, down. Reflections are reflecting over the x-axis and the y-axis. And then our last topic is going to be dilation. Dilation is either going to be a vertical stretch or a vertical compression. A stretch would make it's going to become stretched out, and the compression is going to make it thinner. So a stretch is we're going to be multiplying the entire equation by a value, like a. And a is going to be larger than 1 if it's a stretch. If it's a compression, a is going to be a fraction. It's going to be in between 0 and 1. So write an equation for the transformation of y equals x with a vertical compression of 1/2. So this was my original equation. I'm going to multiply my x by 1/2. So my new equation is going to be y equals 1/2 x. Okay, what type of transformation was made when y equals the absolute value of x becomes y equals 3 times the absolute value of x? So what's going on there? I have a 3 on the outside. It's going to be not a compression. Compression's in between 0 and 1. It's going to be a dilation, but the type of dilation that it is a stretch. So it's being stretched by a factor of 3. So there are 2 types of dilations. A compression, which means that it's being multiplied by a number that's in between 0 and 1, so a fraction. Or a stretch, which means that it's going to be greater than 1. Okay? So next we're going to be putting them all together, and that's why I have this little equation here that should help us out. Oh, it didn't turn out well on here. All right, I'll just write it down. Or we can just keep it there. All right, so we're going to describe the transformation of turning y equals the square root of x into y equals 2 times the square root of x minus 4 plus 1. So how we write these, we're going to start with whatever's affecting the x first. So we're going to work our way from the inside out, okay? And we're going to do our dilation last, okay? So I have x plus 4 on the inside. So on the inside, that's going to be my horizontal translation. That's going to be either right or left. I am adding 4. So that's going to be to the left, okay? So I'm going to move left 4. Now I'm working my way out. I have a plus 1 on the outside, so that's going to be a vertical translation. Am I going to be moving up or down? It's plus 1. Up 1. Okay. And I have a number that's greater than 1 on the outside, so I'm going to be stretch by a factor of 2. Alright, write a new function, g of x, if y equals the absolute value of x is moved up 3, left 2 and compressed by 1/4. Alright, so I'm starting off with y equals the absolute value of x. I'm going to be moving up 3. So up and down are on the outside. So that would become plus 3 on the outside. So I did that. Now, that's up. Now I need to move the left 2. When we move left and right, that's on the inside of my grouping symbol. So if I'm moving left, am I adding or subtracting? It's the opposite than what we normally would think. So it's going to be adding 2. So that's left. Okay. And now I'm going to be compressing by 1/4. So that's going to go on the outside of my group, on the front of my function. So that's going to be y equals 1/4 absolute value of x plus 2, absolute value 3 on the outside, and that's going to be my compress. And so my final equation, g of x, is going to equal 1/4 the absolute value of 2, or x plus 2, plus 3 on the outside.